Hi, and welcome to SPE Live, and today's discussion on digital transformation in production optimization. My name is Nils Kaageson-Loe. It's my great pleasure to be your host for today. If you are new to SPE Live, check us out on social media, #SPE Live, or find us on SPE.org. We have a packed week of SPE Lives. In addition to this discussion on digital transformation and production optimization, all this week we'll be running a short series for young professionals and on career mentoring and sponsorship. That starts later today, so check us out on social media, SPE social media that is, and you will find us there. So a lot of really good information there to come for young professionals. Now, today's discussion, what is the future for oil and gas operations, and specifically production optimization and digital technology? Is it a fully automated, autonomous platform, facilities, and operations? Or are AI and machine learning and the like decision support tools for a slimmed down, highly skilled, and highly efficient workforce? Please share your thoughts, comments, and questions in the social media chat. I'm sure you have a lot of ideas around what digital transformation should be in oil and gas. Now, to answer these kinds of questions and also to about the transfer of technology, knowledge, and skills from highly developed oil and gas basins like the North Sea to places like the Middle East, Africa, Latin America, and even the continental USA. I am joined by an expert panel. So on today's show, we are joined by Pejman Omrani. He is Senior Scientist, TNO, Energy Transition Unit, focusing on production optimization and digitalization in oil and gas and geothermal assets. Joining Pejman, Geert, Ouwerling, Production Technologist, Shell NAM, specializing in visual analytics projects and advanced analytics for production performance and optimization. Also on the show, Luciano Vecchia, Reservoir Engineer, Wintershall, extensive experience in field operations development and reservoir and well management from Argentina and the Netherlands. And also, we are joined by Gerlof Visser, Senior Production Engineer, ONE-Dyas, where he leads digitalization and rollouts for workflow efficiency improvements and production optimization. Gentlemen, very warm welcome to SPE Live.
Thank you.
Thanks, Nils.
Thank you very much.
Thanks for inviting us.
Well, great to have you here. We are going to be talking digital transformation and production optimization. So just a quick reminder to the audience, fingers on buzzers and keyboards, share your thoughts and questions with us. Now, we're going to be talking about digital transformation. So what is the vision ahead for production optimization and operations? Gerlof, let's begin with you. You mentioned before the program that ONE-Dyas wants to be the Tesla of the North Sea. So briefly, what is that vision?
Yeah, so our vision is that we are going to build a new gas production platform in the North Sea, which should be fully autonomous in its production and operations. We call it the Tesla of the North Sea because it has a lot of similarities, in our opinion, to a Tesla. A Tesla right now can drive safely on the highway without anybody really steering it. But so that's also our expectation, that we're going for a safe area where we kind of know our boundaries and we can stay in the highway without any adjustments by people because it's going to be there. Also, Tesla has used lots of existing technologies to get where they are. I mean, they didn't invent new radar systems to try to create self-driving vehicles, or they also didn't try to reinvent the window washer, automatic window washers. So we see, that's why we call it the Tesla of the North Sea. We see lots of parallels with their vision and our vision.
Okay, thank you. So obviously that's one vision, to be this sort of very automated, autonomous operation. Shell holds a different approach. I believe it's very much about enabling the workforce. So what is Shell's journey presently?
Yeah, so especially the NAM specifically is, of course, entertaining quite a number of more mature assets where we are working with the old cars of this industry, so to say, and then with old cars you get more maintenance. And so the the complicating factor of this is we have older technology which we need to use and able to support a lot more decisions that we have to make with shorter lead times. And ultimately, what drives those decisions are the data and the data quality that you have at hand. And so what Shell is really aiming for in this case, and NOM, is to get the people that make these decisions to do that as efficiently as possible, and also to make sure that they make the right decision.
Okay, so really then sort of training the workforce in data analytics, I guess, and data analytics techniques as tools to enable better decision making.
Yeah.
You're in Wintershall, had digital-based operations for a while now, like some other operators. So what's your experience so far to date?
Well, Nils, basically in Wintershall, I mean, when we took over the digitalization process since many years ago, more or less 10 years ago, we were focusing first on try to make use of the already existing data, your real-time data that you have from the monitoring system, and then build on that a new system or a new real-time monitoring system with other added features in order just to give to the operators, and not just only the operator, but also to the engineers that are working on the office, a more clear insight in order just to take decisions. Yes, so the idea, I mean, in the digitalization process, for us is not to replace, I mean, any technology. It's just only, or replace people. It's just only to give us another tool through digitalization to have a better decision-taking process. So this is basically our vision in which we started to construct upon. No? So since, as I said, 10 years ago, I mean, we started with an internal project, which is called the Wintershall Monitoring System. It's a real-time monitoring system, which is, as I said, taking data from the SCADA. And based on that, I mean, we add on top other features in order just to do this. No, so just to give to the operator, let's say, another insight just to take a decision. Of course, that then, I mean, we have on top of this another added features or added value, which is increasing performance or reduced downtimes and increased reliability on the operations.
Okay, thank you. So we'll come back to that in a minute. You mentioned the real-time monitoring system based on the SCADA system. So you're taking in data there and then using it for decision making. Now, all you gentlemen are based in the North Sea operations, so a very mature area, a lot of brownfields. Pejman, obviously a central part of digital transformation in production optimization centers around brownfield versus greenfield. So from a technology perspective, in your experience, briefly, where are some of the stumbling blocks?
Yeah. That's a very important point. I think in the North Sea, if you see a majority of the fields are mature fields, and with a lot of challenges, as let's say other speakers also mentioned, have to deal with a lot of unplanned shut-ins, a lot of interventions are required, frequent maintenances, and the fact that the production from a lot of unstable wells because of the lower pressure in the reservoir. These are the challenges which, in the end, the operators has to deal with it. And also has to deal with a lot of lower margins from this field and making sure that the emission goals are also reached. So there are, let's say, a multi-objective problem with a very complex and dynamic system that they have to deal with it. And still the decision has to be reliable, it has to be fast, and it has to be accurate. This is the part that I think the different technologies can help in the brownfield. For a lot of, I think, companies, maybe brownfield is a kind of a done deal, and they don't want to go in the direction of digitalization of such a process or such a field. But we also have to look that brownfield means a lot of data, because you get a lot of historical data in your archive of years of production and years of operation, which actually this could be used in order to better monitor the processes within the field. So this is, let's say, the part that we see there are a lot of added value which can come from a digitalization of the brownfield. When you go to the green field, of course, the game is different because you start already designing your system in such a way that within years you can improve your prediction models, improve the decisions that you can make on the systems and your maintenance planning. So there you're looking completely into a different line of technologies. You have much more degree of freedom to choose, let's say, a suitable technology for your purpose. And looking into the two aspects, as Gerlof mentioned, the technologies are there. We are not the first industry to look into this sort of a brownfield and greenfield applications, or let's say a new or mature system. So we could learn a lot from the other sectors as well, and seeing which technologies they have used and how it can help us in order to realize our digital vision.
Okay, thanks. And we'll come back to that sort of difference between the technologies as we go on through the discussion.
I think I wanted to just to respond to the other guys as well, because I think our experience is also, of course, mainly from Brownfield, and that's why we think it is possible. We've seen it at Brownfield. Wintershall has got some really good examples as well. We are a smaller company. We are already working with smaller teams by necessity, more or less. So that's why we do think with the Brownfield experience, which is here in the North Sea, we can achieve what we have in our minds in the North Sea with a new asset, of course.
Yeah. So let's keep the discussion around sort of brownfields for the moment. So, we have obviously digital technologies and all kinds of other technologies available to us to sort of help facilitate production. What are some of the challenges in brownfield production in terms of production optimization? We have all kinds of liquid loading, scaling problems that we have. So, a lot of variability. So, Luciano, Gerlof, and Geert, perhaps you want to can you tell us a little bit about what those challenges are like in terms of then, how does that then impact digital transformation?
Well, from the Wintershall side, as you said, we have many of brownfields, very mature gas fields, and as you mentioned also, the main problem that we are facing always is basically solid scaling or liquid loading problems. When in terms of digitalization, what was useful for us was to not just implement or develop along also with TNO some modules in which is gathering the data, as I said, from the SCADA system, and then try just to predict when the salt scaling will occur. And if that happens, also is useful for us just to optimize, the water washing process, for example. So based on this, it's in our case, it was really helpful for us. It's just to have this kind of tool, because this can allow us just to increase the performance of the well by, let's say, adjusting the water wash process, for instance. That is one of the examples. I can give you another examples in terms of not just only, let's say, from the well perspective, but also from the facilities perspective. But digitalization for us, was in that sense, is really helpful, basically. I don't know in other cases, let's say for Shell or ONE-Dyas, it's if they have some kind of experience on this, but for us, was a big, let's say, discovery.
So I can absolutely relate to what you're saying, Luciano. I recognize many of the issues that you are having, especially on the halide scaling issues, which we see on some of our wells, where we actually get to a point where we block entire chokes. So we have choke valve monitoring analytics in place to preemptively water wash these flow lines to make sure that we get rid of the salts. And so those are already some of the examples that we have in place to enable us to keep up the performance that we are looking for from these wells. Within Shell, and especially NAM, I think the complexity comes with the size of our asset. So we're still running about 250 wells or so offshore, from which our main nodal, I think, is controlling about 70 or 75 in parallel. So the difficulty then is not in the individual well performance, but more how do you optimize the system, right? And how do you make sure that you get the correct wells in sequence to maximize your performance across time, and make sure that you do not accidentally liquid load wells by keeping them on for too long, or actually not optimize them by keeping them on for too short. And at that point in time, the vast majority of wells that we have then as a number goes over what you can keep track on as a human. And in that point in time, we're looking to really get some support from computers, and that's where our digitalization comes in. So how do we support decisions on which wells to turn on and off, and how to optimize this production plateau? Not sure how that is for you, Gerlof.
Well, yeah, I was just thinking about it because we've actually 5 years ago we've taken over a field from another operator, and we've seen that their vision, or not their vision, but their focus wasn't fully on this asset anymore. So once we've taken over, we had to do some well interventions, monitoring, but still with the data which is existing, and also demanding the workforce, we could make quick improvements. So yes, I agree totally that if you've a high number of wells and facilities and all that stuff, basically makes it much more complex to quickly go. So then digitalization and scaling up probably is one of the ways to go for you. So yeah.
Geert, you mentioned something interesting there, a systems approach. I think maybe a lot of the audience are sort of familiar with the unconventionals in the US, where there's a big focus on individual well performance and getting that well type, and then using that in sort of AI and machine learning models to sort of create some sort of intelligence.
Yeah.
And that really is more about a systems approach, how you sort of develop a collective. What are some of the challenges around creating AI and machine learning around a systems approach, at a field level?
So the main complexity is around data quality. So there's quite a number of sensors that we can use in order to get an overview. So think position indicators for valves, but also pressure, temperature, flow. There's a lot of data quality issues. So by flow indicators that do not give the right values anymore because they are out of range, or position indicators that are stuck, or temperature sensors which are off. And so the complexity comes at the time where you have 150 different wells to optimize, is the data quality piece. How do you make sure that the stuff that you feed into the model is correct? Yeah, so that is a very time-consuming aspect, and it continuously requires attention because things change. So what can you do to simplify that for yourself? So you build the algorithm such that they hopefully capture that, but it's not a free game. So the sun doesn't go up for nothing, is what they say in Dutch. Ultimately, then, when you feed the model, it's not a very complex kind of optimization, right? So standard operations research algorithms can help us already get to a really good result. But the complexity is in the amount of data and also the data cleanup ultimately. Yeah.
Okay, thank you. I think, Luciano, you were talking earlier about, again, trust in data and models. What's Wintershall's approach been to sort of physics-based models versus sort of just pure correlation-based models?
Well, yeah, I mean, as I said, I mean, a couple of, when we started with this project in terms of the monitoring systems, and one of the latest add-ons that actually we incorporated into this tool was the tool or the module for machine learning or artificial intelligence into the system. Let's say, of course, that what Geert said, of course, that actually you have to have really good quality of your data. We know that from experience when we started to implement this system, the monitoring system. I mean, we spot out problem from the day one. So basically, I mean, what we are doing is try to, let's say, put that data that actually is coming raw, let's say, just to put in that way from the sensors, and then try to pre-process that data in order to be fed into any model, let's say, not just only from the artificial intelligence, but also from the other modules that we have. When we implemented the artificial intelligence models, I mean, was a work that actually took roughly a year and a half, 2 years. I mean, in which we were implementing a lot of ideas, and we were working also with the TNO on this topic. And one of the things that was spot out is that in terms of if you would like to forecast, let's say, behavior of a well, yes, I mean, you have to have, or keep in mind two things. One of them is that not always having a lot of data, I mean, is giving you the correct model. In fact, actually, what you have to have is variability of that data in order to be used, let's say, in a machine learning process. Doesn't make any sense to have 1 year of data always with the same choke position, because it will not tell you anything, let's say. So basically, that is one of the points. Not just only to have really good quality of the data, but also variability of the data. And then the second point to keep in mind is that when you implement this kind of technologies, you have to keep in mind that some of the physics of the system is lost, let's say. So that means that it's useful, actually, if you would like to, for instance, if you would like to do a forecast of a well, for instance, but in the short term. Short term, I'm meaning 1, 2, or 3 months, let's say, as a time frame, just to put it in context. If you would like to produce a forecast of that well for a longer period, let's say 1 year, 2 years, 5 or 10 years, then the purely data-driven, that as is called, let's say, the artificial intelligence, I mean, will not give you the correct result. I mean, at the end, then, I mean, this is based on experience and experimenting on the models. Then you see that you can have really unphysical responses on the model. So in that case, yes, actually, you have to incorporate some kind of module or, let's say, a model to account for the physics of the reservoir, let's say. If not, I mean, it's not would not be a valid approach. At least, I mean, this is from our experience when we incorporate it and then we apply the machine learning or artificial intelligence into our modules.
Yeah.
So I think on this journey, because I mean, we were also involved within this journey of Luciano. The whole idea of using a data-driven models or any machine learning, deep learning models for monitoring or forecasting a certain behavior of your either well or group of wells or your facilities. Indeed, the data quality is important. This variability is very important. And when we're specifically looking into the mature fields problem, the thing is that the historical data might exhibit a certain behavior of the well. So during a stable time that, the life is good and the well is producing without any liquid loading and halite precipitation, we should also make sure that how valid are these data in order to forecast the performance of the well when it goes into a new production mode. So when it goes to the liquid loading mode, when it goes to the halite precipitation mode. And these are also very important. And I think I would like to really emphasize on this, that especially for this forecasting module that we've worked on it in the past, the key was to make sure that you could incorporate or infuse part of the physics or the knowledge that you have about the domain into your machine learning models. The machine learning models can capture the nonlinear behaviors and can capture very complex phenomena, but it's not really supported by any physics. And in order to get a trust into these models, I think especially for our domain, because we've developed a lot of knowledge and a lot of predictive models in the past decades. So if we want to already make a transition to also incorporate those data-driven models, the machine learning or let's say deep learning models within our workflows, we have to make sure that there is an element of the physics either included or we can explain the models somehow. I think this is very important, especially in the view of mature fields. I don't know how, for instance, Gerlof is looking into this.
No, I 100% agree, because I think we need to have, my opinion is we have at least 80% of the time we will have physical models running the show. The optimizer might be more on the machine learning side, but even then you can have different scenarios in my head. We can already pre-program in the model. I mean, if we have an early sign of water breakthrough, we're going to switch from one scenario to another scenario, and then we know what's going on. So yes, I fully agree. We've got already in the oil and gas industry, we've got, I think, over 100 years of experience with wells. I mean, each well is different. Each field has a different characteristic, but in general, the correlations, well, they are more or less still the same, and they still can be applied in the right way. And to touch upon Luciano's story, I think we also need to, for our system, we need to think about what's going to be for the short-term, real-time forecasting and the solution space, and what's going to be in the longer-term solution space. And you can have multiple models running simultaneously or being fed by people running simultaneously. Because in my vision, or in our vision, I think we still have operators, but the operators are more considered to be petroleum engineers who get the warnings from the system if the system doesn't understand what's going on or thinks it doesn't need to react immediately. So yeah, I agree with that approach.
Geert, let's bring you in here. There's also a question from the audience from Jawad Saidi on YouTube. What applications are used to optimize spatial and temporal production optimization for the 250 well system you mentioned? Do you want to sort of talk a little bit to that question, but also I think you had some other comments to add.
Yeah, so of course I cannot go into the specific details of what it is that we do, but you imagine it's running a big factory, you know, with 1,000 production trains, and how do you optimize ultimately the end product that you're making at the end of this factory, right? So I think there's plenty of literature for you to find out what kind of algorithms apply here. It's very conventional rather than very inventional, I would say. So it's not something that is rocket science, to be honest. It's just putting the right puzzle pieces together. And so if we look at how to optimize production, ultimately what you're doing is optimizing a commercial aspect, right? So what I foresee as a sort of ultimate goal is to not optimize production, but to optimize commercial value, right? So you're ultimately wanting to produce the most profitable assets rather than the ones that produce the most. So that's a little bit of a flavor that we may apply in the future. I hope that answers your question. Sorry to be a little bit vague on there, but I think you understand why.
Okay, that's perfect here. So actually that brings up a really good point in terms, I mean, I really liked your sort of indication that is at the end of the day, you're sort of optimizing a system to generate revenue, right? So, you know, how do I maximize my revenue based on known inputs or well streams? So now, Pejman, you talked about, and Luciano, you talked about sort of physics-based models and variability. So here, I guess the challenge here is that, you know, we have relatively small, highly variable data sets that are anchored in physics in terms of the subsurface. And as an industry, often people from outside the industry point the finger at us and say we're very slow at adopting digital transformation. So when we adopt technologies from outside the industry, often these technologies are based on very sort of more uniform data sets. What are some of the challenges that we face to sort of bring in outside technologies to help us in our digital transformation journey in production optimization? Pejman, let's begin with you, perhaps.
Yeah, sure. I can start. This is a very important point. Maybe just a small information, kind of background information from our company, because we are a research institute for applied sciences, which TNO is not only active in the energy sector, but we are active in let's say all the other sectors like mobility, defense, let's say ICT. So it's really broad that let's say the type of research we're doing. And the start of the digitalization journey, or let's say looking into the technology development for the data-driven decision support, we actually looked around to see what's happening in the other sectors. And having a colleague who is working in defense or working in the dairy farming, it actually enabled us to being able to investigate what's happening in the other sectors. And indeed, a lot of tools has been developed for the ICT sector, for the defense sector, which could bring added values. But at the other hand, we also have to look a little bit into that was a bit of a, let's say, eye opener some years ago when I started this journey, is that we have to really look into what's the purpose that we want to use this data for, and do we really have a, let's say, a one-to-one similarity with the other sectors? Can I just take an example from one sector, bring it to ours? The answer is a bit of a yes or no. As an example, we talked to a colleague who's working in the smart dairy farming. They want to optimize the milk production and being able to detect anomalous cows. And this is a very inspiring example, because first of all, the type of data which comes is going to be quite, let's say, system dependent, or how you actually install your sensors. Not so much data or homogeneous data will be available. And in the end, we also, as Geert mentioned, we want to also optimize our production, optimize our venues, and if there is any anomaly, we want to just detect and act upon it. So we found it as a very inspiring case that yes, a lot of those examples could also be applied to us, and that might be a little bit in contrast with some of the technologies which has been, for instance, designed for perhaps social media. There is completely different to identify the correlations and the causalities between these data. And within our sector, we have a very positive advantage, which is a lot of things are driven by physics. So we don't have to invent that when your choke is zero, the production is going to be zero. That's given. We know it. A lot of things are driven by pressures, flow rates, temperature. And this can help us in order to better utilize the technologies from the other sectors when it comes to us. That's a little bit maybe from the technology perspective. I mean, from the operation, perhaps, I don't know, Luciano, maybe you can add something into that, how you see it.
Yes, I mean, regarding that, I mean, I can come back. I mean, when we implemented our first time, I mean, this module for machine learning, I mean, it's in which, as you said, okay, I mean, some of the ideas from other sectors actually was the first approach that actually we took, you know, so just to bring models from other sectors and try to apply it to our sector, to our purpose. And of course, as Pejman said, I mean, it's let's say that we were doing a lot of testing regarding which kind of the data that actually we have available, because actually right now, I mean, because of the monitoring systems, you have available data for almost everything. But basically, I mean, it's not that all of those data actually is applicable to your purpose, to your models. And one of the examples is when we started with this journey to apply machine learning's algorithm. At the beginning, I mean, we thought that just only with the normal or the let's say the most common parameters that actually you can measure in the well, that was flow rates and wellhead pressures and temperatures, were not enough, let's say, just to model, let's say, the behavior of the well. And then at the end, I mean, we discovered that also one huge impact in terms of the forecasting was the choke position, for instance. So in our models, actually, you have to have it. So that's it. One example in which, let's say, how to, although you have already test models in other fields, but actually it's not that you can transfer it one-to-one. That is for sure. I mean, it's not working like that. So you have to do your homework as well, let's say. No, so actually you have to test it. I mean, it's not that this. I mean, you can take it as a basis, but then you have to work on that, and then doing that, actually you fit it to your purpose, basically.
Gerlof, do you want to pick up on this? I mean, I'm just thinking back to your earlier comments about your vision of being Tesla of the North Sea, so a fully autonomous system. You know, how is that going to sort of build on sort of picking out the anomalous wells or performances, you know, in a very automated system?
Yeah, I'm gonna pause that question as well. I'll probably come to it because I wanted to. I just had another thought as well on the optimization what Geert mentioned. That we want to optimize overall revenues for our company for this our vision Tesla of the North Sea. We've actually set it a little bit broader. We want to reduce lifetime costs without harm to the environment, and I think that's one of the issues we're actually fighting here with production optimization these days. Now we can optimize on so many more variables than we used to do. I mean, back 20 years ago was more, I want to maximize production, but now we can actually also try to minimize venting or reduce fuel gas usage on your system. So I think that's also really that's probably also part of the game of production optimization these days. Now it's broader actually. So yeah, your question on how can we? Can you repeat your question, please?
It was really sort of you know, thinking about going to an autonomous system. How can an autonomous system deal with anomalies in, you know, a system? You know, it's not like a production line of in a manufacturing facility, right? You have a lot of variability within time as well as in specific locations. So it's a very complex system to deal with. So you always require a human interface, or can you go to an autonomous system as your vision would imply?
Yeah, I think so. So on this, I think we will do it in phases, I think the plan is to do it in phases. I mean, during the initial startup of the well, it would be amazing if we can have it autonomously running, but our vision is, well, we're probably not going to be able to, but for your semi-state production environment, you should be able to just have your wells running in steady state. You've got your well model, which is explained by Luciano as well. That will be your reference case. If you see, well, if the system picks up any deviation of the trends, depending on what kind of deviation it is, it either knows what to action on, and also we need to have that's the most important stuff, of course. You need to have your objective functions or your objectives for the functions in place. For the for our vision of to reduce cost harm to the environment, I mean, our objectives will be based on quantity, quality, emissions, and also efficiency. So that's if you know what you're gonna go for, you know how to optimize it, and you can have your system work. Most of the time, it will be able to work. The other hand, however, on this or the other side of this is how are we gonna optimize production with also taking maintenance strategy into account. That's going to be the harder part. So I think for the real-time production optimization, we should be able to do it. The maintenance strategy in real time, we should be able to do it. But how are we going to connect those dots? That will be our challenge for the coming year. Because I mean, the easiest way to maintain your facilities is just to shut it in. But that hampers the production again.
It does, yeah. So great comments there. So in terms of the challenges facing you in terms of both production optimization and maintenance in the future, then combining those. Now, if we turn the conversation slightly, the North Sea, which has been the focus of the discussion, very, very sophisticated region in terms of oil and gas production. It has a very, very long history, very sophisticated operations, very good infrastructure, both in terms of pipes in the ground, but also telecommunications. If we think about how we would transfer this technology and know-how to other regions in the world, for example, Latin America, Argentina, Luciano, given your experience there, what would you think are some of the challenges for those kind of operations to sort of begin to adopt the digital transformation?
Yeah, well, I mean, talking to Argentina in particular, let's say that one of the major things that you can face is that sometimes, I mean, it's you cannot have, let's say, a good quality of data, or even, I mean, right now you have still operators that are still managing, let's say, the fields with Excel files and recording, let's say, everything on paper. I mean, it's nowadays, I mean, it's these things still happen. So I guess that one of the main challenges also, I mean, from that perspective is to make like a change of mind, let's say, in terms of that sense. And then actually, I mean, the operators there have to really focus on if they are going to drill new wells or they are developing new fields, they have to keep in mind this kind of topics. Yes, I mean, in terms of data gathering for them to be used, let's say, in any digitalization process. Of course, that in Argentina you have operators that they are doing that, but that are the major ones. I mean, it's so the major operators like YPF or Pan American Energy or in that case, I mean, or Total, for instance. I mean, I know that they are doing that, but then you have a lot of really small operators, yes, that says that I mean, they are not, I mean, really focused on that part of the topic. And then at the end, I mean, if those kind of companies or those companies, I guess that then at the end will face some challenges in order just to move into this digitalization. So, and then of course that you have to keep in mind that all the oil fields that you have in Argentina almost are in the middle of the desert. Although, I mean, you can have certain kind of communication to the field. It's not that is completely reliable sometimes. So depends, actually heavily depends on the operator itself. I mean how they were developing the communication network inside the field. So that is the other leg, let's say, of this point.
Oh, thank you, Luciano.
Can we just one thing I can just put it, sorry. Just with the last two inputs are pretty interesting to me, because on one hand I see there is a added value being seen if we can combine production optimization with maintenance planning, and this might often happen in two different silos or not being really integrated. And on the other hand, I think we still see there are a lot of workflows which are still Excel based, on the paper, quite decentralized. And I think that's also a very important aspect. The digitalization can help in integrating this data so that everybody can work with one source of data. Just before this live session, we had a chat with Geert. I think he can tell us a lot about it. Geert, do you want to add something?
Yeah, so I think NAM is quite exemplary in that sense, right? We do operate about 20 different platforms in the southern North Sea, so both UK and NL side, accommodated by 2 walk-to-work vessels. So we do not have helicopter flights or as little as possible, only to the main platforms. And we use those boats to do production optimization, so chemical treatments on wells, as well as maintenance. So you're looking at really the production-related maintenance, and we try to do as much as possible. And really here comes the integration part, right? So I can go with the boat tomorrow to a place where I either certify a live boat, or I do a foam treatment on a well and I get some 100K production back. So how do I make these value, safety, maintenance trade-offs, and how do you make sure that people use the same data to drive that decision, and how do you make sure that they actually know it's the right decision, and what data do we have in place to support that? And I think that's really a fundamental issue more for us, given our size. It's really that integration part, right? So we're not looking to the specifics of operating and performing a single well, but more how do we optimize across the portfolio to make sure that ultimately at the end of the day, the bottom line is fed as well as possible. And I really like Gerlof's comment on the environmental awareness. So we're doing that separately outside of production optimization with all kinds of greenhouse gas emission initiatives also in the digitalization portfolio. But we really keep them separate. Yeah.
Geert, I just wanted to pick up on what you were saying there, and also given your experience in NAM operations, and you as a young professional, I'm picking on you specifically here. So if you were to now travel to a different location in the world, say Argentina or the Middle East, given your experience with NAM data and systems, what would you take with you to say, okay, this is how we can transform an operation somewhere else?
Yeah, so I think about a year ago, I went on holiday to Madagascar, and it's fairly upcoming, as in economically, and it was very difficult for people to buy a car, but everybody has a cell phone with internet, right? So apparently that network of communication can be set up fairly quickly. And maybe that is something that you should initiate primarily, is how do we get the communications networks in place for the facilities to actually transmit that data? And is there an added component which helps also the people around it living there? So ultimately, it's all about connectivity, right? Are you in the cloud or not? Yeah, and can we then use that data to actually drive those optimization decisions?
No, perfect answer. Thank you. Now I'm going to turn to an audience question. So I'm going to aim this at Pejman first of all. So Elijah Kiplomo on YouTube, working on a project using wellhead data, PVT, and also sand and water cut. How will I be able to factor in the variations in the technical specifications of the equipment using a machine learning model?
That's a very good one. Yeah, because that's indeed, I think, one of the essence of getting a successful machine learning model is in the end to incorporate those information from your equipment, from the PVT data, from your, let's say, different measurements incorporated in this. So there are techniques there. I mean, I don't think maybe in the live we would really like to go in that direction to the technical details, even though I would love to talk about it, but for time reasons I will not do it. But maybe I would like to bring one small remark on this. We always go in the direction of the hybrid modeling, so not being married to a machine learning, be this, let's say, a young fresh guy who want to change the whole world, and not stick too much to the physical model. Stay in between, see how much data do you have available, and how good can you model and monitor your process with your available knowledge and models. If you can do it with a simplified analytical model, why bother building a machine learning model? If it's too complicated, you don't have any other choice. So you have to go to the machine learning models, and the best is just to stay in between. It's very good to incorporate as much as you can from the physics, and couple all sort of reservoir models, sand models, water breakthrough models to your machine learning models. There is a point, be careful, because if those models are also not calibrated, if you couple a reservoir model to your machine learning model and that reservoir model is not accurate and it's not calibrated, garbage in, garbage out. That's going to be the factor. So it's best to incorporate the knowledge and domain expertise and physical model to your machine learning model to get the best performance. But be careful that you also have to let's say, take some effort to make sure that your physical model is also doing a good job.
Perfect. You others want to comment on that from experience-based basis, Luciano?
Yeah, actually, I mean, it's what Pejman mentioned. Actually, I agree 100% because I mean, it's we face it. I mean, during our work. But basically, I mean, it's the statement that okay, that you have garbage in or out. Let's say if your model is not calibrated, I guess that also is the statement for all the models. Basically, I mean, doesn't matter here if we are talking about machine learning models or even a reservoir simulation model. I mean, numerical model. I mean, it's applicable for all type of models, even for a Prosper model, if you like. So it's so yes, I mean, I agree 100% with Pejman regarding this sentence in which yes, I actually have to analyze if the machine learning can give you an added value, basically. So it's if can give you an added value, yes, it's useful to use it. But if not, I mean, in the market or even, literature, you have plenty of models. Probably, just
I think we may have lost Luciano there. Yeah. So let me bring in another question from the audience. Andrew E. earlier on YouTube was asking what programming or languages are the best place to start for using data to create models and tools. Heard you nodding there.
Yeah, to be honest, there's not a right and a wrong in this, right? So learn something that you ultimately are going to benefit from, not only for machine learning or for data interpretation, but something that can also help you outside, right? So we do, and I think many people do that a lot in Python. I can highly recommend it. It's fairly easy to pick up, and it gives a lot of functionality, right? So I do my house economics in Python, but I also do production optimization in Python. So it goes both ways. Yeah, and what is really, really important to learn, I found, is to simply understand how data resides. Yeah, so what are databases like? Where's data stored? How can I access it? How can I make sure that I get the right data and the right type and in the right quality? And how do I find anomalies? And I think that is really important as to learning and understanding how to work with machine learning models, is really understanding the data you work with.
Yeah, I think
programming.
Sorry.
On the coding side, I think the TNO. Well, we've also developed a model of TNO in MATLAB. That was basically because it was the most commonly used, more or less free programming language. So you've got all the universities in the world were using it at the time. So you've got lots of discussion for where you can find solutions and you can help people with it. And nowadays, I think it's Python. So that's probably also one of the factors you need to figure in.
Yeah, and one of the beauties of working in Shell, I think, is that we get that support, right? So there's a team that runs the backend who are working on a platform that supports the data, and then they get engineers like myself with the freedom to actually learn these languages and come up with their own solutions and build business cases to implement them and code it ourselves and run it in a production environment. And it's really enabling the engineers on quality data to actually come up with solutions that bring value to the business. And so we get that value from our own day-to-day job rather than a lot of support from outside organizations.
Yeah, that really reinforces what you were saying at the beginning of the program, where you're using digital tools to reinforce the engineering and sort of support decision making.
Yeah.
Pejman, I want to turn to you now. So, what we've just been talking about is really knowledge transfer, answering some of these audience questions. Talk to us a little bit about sort of, workshops, joint ventures, that sort of thing, how that underpins knowledge transfer and benefits the industry.
Sure. Yeah. I can maybe perhaps give two examples, starting with the developments in the past years, together with the operators that we have today on board, with the Wintershall, with NAM, with ONE-Dyas, and also together with others, Total, and also EVN. We've developed a lot of these technologies and also assess a lot of these technologies within a joint industry projects. This is, I think, an excellent opportunity, not only, let's say, for a knowledge development side, that you can get the operational view on this, but in a recent program that we worked on the detection of anomaly, I think the beautiful thing that happened was information sharing, was knowledge sharing. And in this case, we could even bring the information from the various operators into a kind of a centralized toolbox, and being able to benchmark the behavior of, for instance, the halide precipitated well of Wintershall on the sum of the signatures that they have observed in another operator. And this, they don't have to access the data from each other, but just this information sharing, knowledge sharing, and being able to assess the technology together, which everybody has its own doubts and questions about it. I think that was an excellent platform which we could realize this. This is of course within the projects, but on a broader sense, what I would really like to also announce over here is that on the production optimization, not only the topic of digitalization, but also what is the best way to lift within your mature fields, what's the best way to manage your topside facilities. We always try to organize under, let's say, the SPE organization, a yearly workshop in the Netherlands on the topic of production optimization in oil and gas assets. And this year, well, due to some obvious reasons, we could not go on with this event. This yearly event, we're going to go on with it hopefully next year. Happens either last week of October or first 2 week of November. So that's the kind of timeline. And the discussions that we had today, next to all the other challenges that you can imagine of production optimization of mature assets, is going to be presented there by a lot of different operators. So I would like to also, take this opportunity to announce that if you would really like to share your stories with us or hear about the challenges in North Sea, how it can be applied for your fields, then this could also be a nice platform to join.
Yeah, absolutely. That'd be an excellent venue for people to begin to share knowledge and history and experiences. Just to sort of begin to round us off here, there's a great question from Hector Clear on YouTube. It goes back to sort of, joint ventures, workshops, joint industry projects. So what's your opinion about publicly releasing some of the production data to advance the development of clever algorithms? Obviously production data is very sensitive. It has a revenue stream attached to it. So, people are very reluctant to release that kind of data. But just briefly around the table, what's your views to this kind of approach to, joint industry development, if you want? Gerrit, let's begin with you, perhaps.
Yeah, so ultimately, I don't see an issue if you don't know what it is you're looking at, right? So I would be very reluctant releasing company information with regards to production data if you could figure out where it came from. If you cannot do that, then there's no real argument that can be made to not releasing it. Yeah, but does it require the necessary scrutiny to make sure that that's not the case? I think so. Yeah.
Gerlof.
I think actually it's already been done in many countries already. I mean, in the UK, they've got a big the OGA. The OGA has a big database already, which is public. I think also in the Netherlands, we've got a NLog website where you can find lots of data, and then Norway's got a similar approach. So I think it's already starting to happen. And so we've got some joint industry projects in the Netherlands, and one of my suggestions last year was to have some kind of algorithm to find production-related issues based on location of wells. And but in the end, it didn't go through because most of the issues were already known for all the operators, except for our new to-be-drilled wells. But that's, of course, another issue.
Luciano, any thoughts?
Well, actually, I mean, it's as Gerlof said, yes, I mean, right now in Netherlands, you have, this kind of databases in which you can gather some data. Of course, that's probably, you don't have really in detail data. To be honest, I guess it's so probably depending on which is your purpose for usage of that data, probably can be useful or not. It's so that depends on the objective of your work. But I think that this is a personal thing, But if the industry wants to tend to that way in which, or that path in which you can share your data, probably you have to have a more strict framework, let's say, or at least a clear framework how to do it. So far, it's we know that is because of okay, you can have this data from NLog, let's say, in Netherlands, but probably for some other specific work is useful just to have, as happened with this joint program that actually mentioned that Pejman mentioned, no? So in which it's we had this program with a lot of operators that we were contributing with their data, let's say, but it wasn't a small group. to be honest. I mean, and then it's so we put everybody. I mean, it's we agree, let's say, on how to do it. So if you want to translate this kind of approach to an industry base, I mean, I guess that you have to have a framework just to do that, I guess.
Yeah, I think, for me, based here in Texas, the Texas Railroad Commission has a huge database on all well productions. I mean, there is a time lag as to when that data gets loaded in, but it has a very big impact on how companies, particularly small startups, actually can develop new technologies looking at production optimization. But goes back to, as Luciano was saying, how you regulate the data and manage the data and its accessibility. Just closing in here now, I mean, let's go around the table, one quick soundbite on what your thoughts are for production optimization, digital transformation going forward. Let's start with you, Pejman.
I think looking into the trends, we see things are not getting easier for the production optimization. It's just getting more challenging because of, let's say, aging of all the reservoirs and the assets. And one of the other things also my take from this discussion was that it's not a single objective problem anymore. We are looking into a multi-objective problem to optimize production, optimize operation, and in minimizing emissions. And I believe that digital technology could be an excellent enabler to help companies to actually integrate these multiple objectives for a very complicated process.
Thank you, Pejman. Geert, do you want to sort of follow up?
Yeah, so what I find really important to give as a takeaway is to think, how can we enable being at the verge as an oil and gas industry of digital development, especially comparing to the big tech companies? How can we leverage the knowledge that is already there and the data that we have, because there's a lot of data, to as many of the employees that we have within oil and gas as quickly as possible, right? So it's about accelerating that development through getting that accessibility. So for all the operators out there, that platform that we have, where we see that we have the connectivity to get the data that we need and the quality that we need, especially on, for instance, production optimization, and how quickly we can share that across our peers in the different operating companies in Shell, is tremendous and helps us accelerate these things so much quicker.
Excellent comments there. Thank you. Luciano.
Yes, I mean, it's from my perspective, I mean, it's digitalization itself as a topic. I mean, it's for the oil and gas industry right now. I mean, is getting more and more attention, as you may see. I mean, right now we have a lot of developments in for different applications. I mean, in the oil and gas industry. I'm pretty sure that it's a tool that, or it's a way in which, I mean, companies can benefit from, just only from different points of view, let's say. I mean, it's not just only from the optimization and the performance, but also, as was mentioned, I guess, by Pejman, also from the HSE perspective, so how to manage also emissions, for instance, so it's just applying this kind of technologies. I'm seeing that will have a big impact in this industry. It's started to have a big impact, and we will see more and more applications of this technology. It's just only a matter just to see it from the last years. I mean, it's how the digitalization topic is gaining more interest, and even in international conferences, for instance. So all in all, I guess that is something that we have to keep moving forward. Yeah.
Thank you, Luciano. Gerlof, let's finish with you. You had this ambition of being Tesla of the North Sea.
Yes, and we still have it, of course. I mean, it didn't change in the last hour. But yeah, I think as well, I mean, the main takeaway is how, I mean, with all the data and all the connectivity which has been discussed and all the different disciplines which are required for these optimization purposes, I think it will also be a change of how we'll work. I mean, it will be much more interdisciplinary. You need to have information from the HSE department, which is currently with Geert, it's not directly related, but you also need maintenance data. We're going to combine everything, and at the same time, and that's, as I mentioned before, the biggest hurdle will be to convince the regulators. So I think if we can do a really good job with our production optimization, digitalization work, then we can probably also go forward with the regulators, and we can make our offshore operations much safer by not having to be there anymore. Because that's, of course, also one of the goals with the unmanned platform. You basically don't have to be there anymore. Yeah.
Thank you, Gerlof. Perfect. Yeah, I think that's a really good ambition to have as an industry, is to make it safer and more efficient. Gentlemen, thank you very much. It's been an excellent conversation, very informative, great audience communication. So Pejman, Gerlof, Luciano, Geert, thank you very much for your time today and all your insights. This will be an onward discussion because it is obviously an ongoing journey for all of us. So it'll be very welcoming to have you all back in the studio later on next year to discuss further on this digital transformation and production optimization. So thank you very much. Thank you, audience. There are more SP Lives later on today, so please catch those. SP Live is made available to you all by SPE Foundation sponsorship. So thank you, SPE Foundation. And to all of you, thank you very much, and join us again later on. Thank you. Been great.
Okay. Thank you.
Thanks.